Yes, hello. Good morning, everyone. So, those who are present, could anyone please confirm whether I am audible or not? Those who are present, please do confirm whether I am audible or not. Yes, good morning, Sriyoshi. Okay, okay, good morning. Okay, let me wait for 5 minutes, then I will start. Today, we will talk about the part of serializability, that is the part of scheduling, view serializability, and conflict serializability. What are those? Yes, Tushar, I will be sending all the PPTs by today itself because this will be your last class. From the next very class, you will having the exams. So I will be sharing all the PPTs in the Telegram group. 2 to 3 minutes, then we will discuss the scheduling part of the DBMS. How to convert from one scheduling to another scheduling, that thing I will be explaining. It has an example, solved example, so it will be easier for you to understand. Incorrect summary problem. Uh, Let me check. There will maybe some other names to that. Precedence graph. Which precedence graph? Oh, incorrect summary problem is the concurrency anomalies. Yes, it has. This is the thing when this is the actually a problem. This incorrect summary problem is actually a problem. You do one thing, you can, yes, serializability I will be telling today itself. Yes, so let me explain you this a bit. This is one of the most concurrency anomalies, means the problem with the concurrency. This is caused when one of the transaction is executing an aggregate operation on several data and the other transactions are updating. Suppose there are two transactions. One transaction is operating on the aggregate operation on several datas and other transactions are updating one or more of those data items. Due to this problem, it is causing the inconsistent database state. Suppose, let me give you an example. Suppose I have two instructions, two transactions, transaction 1 and transaction 2. Transaction 1 is occurring only on the two operations, that is, suppose 50 is deducted from account A and 50 is added to account B. Okay, so A equals to A minus 50, write A, B equals to B plus 50, write B. Okay, at transaction 2, in transaction 2 what happens? Suppose it is calculating, doing the average, sum plus C. Suppose there are two, sum and average. I am calculating the average of four few numbers. So what happens? It has also the term of A and B. Now A has 1000, B has 1000, C has 1000 rupees. Okay. Now if I read A, B and C and perform the sum, then what happens? Transaction T2, in T2 what happens? In T2 we are having the averaging transactions. So T2 reads the value of account A and after A is updated, and reads the value of B before B is updated. A will be read after updated and B will be read before it gets updated, because it is arranged in such a manner. Okay, I can't display this image in the screen because it's with my copy, so I will be sharing you in the Telegram group, then that will be easier for you to understand. The portion that violates is when I am reading A, so it should read the original, but it is reading the updated thing. It should read the original value of A, but it is reading the updated value of A. So there it gets the problem. All the transaction of T1 is executed on 1000, but T2 should also execute on 1000, rather it is updating or it is performing on 950, because it has 1000, it has deducted 50, so we have 950. For gate, maximum questions comes is from the conflict serializable and views serializable. Let me show you. I think my screen is visible to you all. These things I already told you on the previous class. What is scheduling? Schedule is the abstraction of the activity of simultaneous transactions. Means when I am transmitting, when I do simultaneous transactions, it is the overall thing. WWWR, RWR, yes, these are all the basic things. Write after write, write after read, read, write, read. Phantom. But maximum the conversion comes is check whether the transaction is view serializable or not, or check whether the transaction is conflict serializable or not. This kind of thing comes in the gate. Okay. See, schedule has few transaction identifiers like DB reads, means database reads, database writes, and the data they operate. Commit and abort are the things that is required. You can write abort or you can write rollback, means rollback to the original state, rolling back to the original state. And commit means confirming that the transaction is being completed, confirming that the transaction is being completed. Now these are few scheduling notations that you need to keep in mind. That is SA. SA means a schedule of one or more transactions. Schedule A. Yes, cascading rollback. Then these are all the terms. Okay, these things will come on the semester thing. Cascading, what is cascading rollback, how it happens, these are not going to come on your gate. Gate generally is a problem based thing. Okay, you will get the questions based on the problems, not what is that or define that, write the properties on these things. Ti are the set of all the transactions. Okay, and Ri is the read operation, Wi are the write operations. Ai transaction, I aborts, and Cih commits. C for commits, A for abort. These notations you need to keep in mind. Now, what do you mean by serial scheduling? First, you need to keep in mind that every scheduling or every transaction must follow the ACID property or ACID behavior. Okay. Now, if Ti does not overlap with Tj, Ti is one schedule and or one transaction set, and Tj is another transaction set. Right? If Ti does not overlap with Tj, then ACID property is maintained. Means does not overlap. What do you mean by that? Means Ti does not, any statements of Ti does not directly affect on Tj. This means both these transactions are operating separately. They are not overlapping with each other. If they are not overlapping, if they are not dependent on each other, then ACID property is maintained. This is known as serial scheduling, means two transactions are performing serially. If their question comes, check whether the schedule is serializable or not. This means serializable schedule means is one which is equivalent to the serial schedule. Okay, now there comes the important thing. When we can say that the transactions are conflicting, what are the conflicting instructions? Which instructions I can tell as a conflicting instructions? Suppose instruction L1 and Lj of the transaction Ti and T1 respectively conflicts. When I can say that these two statements conflict if and only if there exists some item Q accessed by both L and J, means there must be some data that is accessed by both the transactions, both the statements of both the transactions, then only the conflict can happen. Like, let's say the examples. First conflict statements or instructions is if Li of Ti, means instruction I of transaction I. Read Q, read Q. Both are reading a same data. So no conflict will happen. But if one will read Q, another one is write Q, then the conflict will happen. Or both the write or one write one read, then on the same data, obviously both will occur on the same data. If both occurs on the same data, this read and write operation, then only they will conflict, they will produce a conflicting instructions, they will produce a conflicting instructions. So what is conflict serializability? From this confliction, it comes to a new serializability, that is the conflict serializability. What is that? If a schedule S can be transformed into a schedule S dash by a series of swaps of non-conflicting instructions, then we can say S and S dash are conflict equivalent. Means, suppose I can say, because both are reading, if I read some data, then how can it conflict with each other? I am reading both the data. I am not making any kind of changes, then how can it make a conflict, right? If a schedule S can be transformed into a schedule S dash, means if when I found कि I have a conflict instructions, and if I can transform that conflict instructions to the normal instructions or non-conflicting instructions, then we can say this both by obviously by doing some swappings, then we can say that both the equations are conflict equivalent. How? Let's check. See schedule 1 and schedule 2. Schedule 1 can be transformed to schedule 2. Check. Schedule 1 is the original thing which is conflicting. Say T1 read write A, T2 read A at the same time. Then it can conflict. But if I convert the schedule 1 to schedule 2, then I can say schedule 1 it is conflict serializable, means I can remove the conflict and I can make it conflict free instructions by doing some kind of swappings. See, I have moved read B before read A in transaction 2. That gives us the time to complete the operations of read A, and we can easily transact on transaction 2. Is this example clear? How to remove conflict from the scheduling? See, schedule 1 is actually the conflicted scheduling, means we are facing the conflict problem. Conflict instructions is there because write A and read A are there in transaction 1 and transaction 2 respectively. Now this will create the problem in updation of the database. Now I need to swap some functions if it is possible, obviously, to make it conflict serializable. That's what I have done in schedule 1, and I have made schedule 2 from schedule 1, which is conflict serializable. I have removed the conflict from schedule 1 by doing some swappings. Means I have removed read B from downward to upward so that it sometime read A and write A gets in T1 so that it gets updated on the database so that I can access the A from transaction 2. Next, check. This is my example. Okay. T1 is dependent on T2, then T2, again T1, then T2. Means 1 T1, then T2, then T1, then T2. This way we have this schedule. Now how to check for the conflict serializability? How to check for the conflict serializability? Consider the schedule T1 R1X. T2 T1 has R1X on the first and R1X at the last. T2 has R2Y, R2Y, W2X, and T3 has RW3Y at the last. Check for the conflicting actions. Two or more actions are said to be in the conflict. These are the statements. Okay, remember that. Two or more actions are said to be in the conflict if number one, the actions belong to different transactions. The actions belong to different instructions in the transaction. Number two, at least one of the action is a right operation. If one of the operation is the right operation, then if we can say it is a conflict. The actions such as the access the same object when a same object, that is x, suppose x is read and written by one transaction, then we can say it is conflicting. So what are the areas in the above schedule which is conflicting? R1 in T1 R1x, in T2 WX, and in T1 R1x. These three is conflicting, this one, and this one, right? These three instructions are conflicting. These three instructions are conflicting. While these following sets of instructions are not. Last, read, then ry, rx, these are not conflicting to each other. Then what we will do? Check for the cycle in the precedence graph. First draw all the transactions. We will check for the cycles. Means how this is forming this kind of circle. We have to check for the cycles. First draw all the transactions, then check if there is a TX that reads an item after a different TX writes it. Next, we have T1 that reads X after T2 writes it. So, draw arrow from T2 to T1. Draw arrow from T2 to T1 because writing is there after the read is happening. Next, check if there is a TX that writes an item after a different TX reads it. We have T2 that writes X after T1 reads it. So T1 to T2. So T1 to T2 will happen. This operation is valid. We have this operation here. Next, we also have T3 that writes Y after T2 reads it. See, T3 which writes Y after T2 reads it. So we will have T2 to T3, T2 to T3. Next, check if there is Tx that writes an item after the item X. No such is there. So this is the final cycle. This is the final cycle. T1 and T2. So the graph can be cyclic. As this graph is cyclic, so we can say that it is not conflict serializable. As we can form the conflictness, so we can say, as we can draw the cycle, so we can say that it is conflict serializable. Next is view serializable. Consider two schedules S1 and S2 where the same set of transaction is there. Okay, let me show you by the example, that will be easier. T1 RA WA, T2 doing the WA in between RA and WA, T3 W at the last. We can say that this is a view serializable if it is view equivalent to a serial schedule. This is probleming a serial because a read A and write A happening. So if we do it together, if first transaction 1 completes write A, then transaction 2 performs write A, then it will be removed. S1 is not equivalent to S2. Okay. By this way, we can do the view serializability as well as the conflict serializability. This way, we can convert. Let's check the example. See, check whether the schedule is view serializable or not. This is the transaction. What you need to do, you need to arrange this transaction first. By this way, we arranges the transaction first. T1, T2, T3. First is R2B, R2A, R1A, R3A. We have to arrange these things in such a manner so that it does not get conflicted. And we'll check whether it is view serializable or not. You all do one thing. You try performing this scheduling, then it will be easier for you to understand. I am sharing this PPT on the Telegram group. Check and try performing this scheduling given on the quiz. Okay. Okay. Perform this assignment. These are all gate questions. Perform these assignments. Okay. Thank you.